Hello everyone, I am Yi-Pei, Professor of Mechanical Engineering in NTUST. This presentation is an introduction to the course Mechanisms and Dynamics of Machining. This slide shows the email address of the teachers and teaching assistants. Professor Yi-Pei, Professor Chen, and the teacher assistants Sebastian, Xu and Xu. If you have any questions about this course, please don't hesitate to contact TS of teachers. I will talk about the following course. I am your teacher in the second part course. This course has 4 topics: static dynamics force analysis of mechanisms, profile can design, Spur Gears, and gear trends. The first topic, static and dynamic force analysis of mechanisms, concerns all the laws in a mechanism. This topic continues from the previous part. I expect you to have a solid foundation in analyzing the position, velocity, and acceleration. And if that is not the case, I strongly encourage you to review previous chapters before studying this course. This is a can mechanism. These are the can and furrows. The animation shows continuously rotating cans, producing reciprocating linear motion of the furrows. This mechanism is used in the internal combustion engine of a vehicle. A can is a rotating piece in the mechanism used, especially transforming rotatory motion into linear motion. The second topic, profile can design, will teach you types of planar cans and design the can profile. The gear mechanism is an insertion power transmission element that can transmit power and motion from one shifter to another. Transmission systems use many types of gear mechanism. They are classified into 3 groups: parallel axis gears, intersection axis gears, and cross axis gears. Spur gear and helical gears are parallel axis gears. The axes of the 2 gear shifters are parallel to each other. Strut bear gears, spine bear gears are intersection axis gears. The axes of the 2 gear shifter intersect. Wound gears and hydraulic gears are crossing axis gears, and the gear axes do not intersect. I will talk more about spur gears and the helical gear. Spur gears have straight teeth that are produced parallel to the axis of the gear. They are the most common type of gear and are also the most simple. Helical gears have teeth that are set on an angle to the gear axis. Since the teeth engage more gradually, they have a larger contact ratio that enables a smoother and quieter operation than spur gears. Helical gears also have greater tooth stress and higher load-carry capacity. The third topic will focus on how to design and manufacture spur gears. Let's talk about the gear ratio. For machines, the output power equal to the input power times the gear efficiency. And power is the torque times the angular velocity. If gear efficiency is 1, The ratio of the output torque to the input torque is equal to the gear ratio. Thus, we can multiply the motor's torque by the gear ratio to get the output torque. Gear efficiency depends on the categories of the gears and the gear accuracy. The efficiency of parallel axis gears and intersection axis gears are around 18 to 19%. And the crossing axis gears have a lower efficiency of 14 to 18%. The topic gear trends will talk about how to calculate the gear ratios of the gear trends. Three types of gear trends are often used in industry: simple gear trend, compact gear trend, and the planetary gear trend. All gear shafts in the simple gear trend and the compact gear trend are fixed to the frame. From these two figures on the left side, you can see their difference. A simple gear trend has only one gear on each shaft. In a compound gear trend, each intermediate shaft has two gears, rotating at the same speed. A compound gear trend has a much larger speed reduction from the first shaft to last shaft with smaller gears. If a simple gear trend gives a high reduction ratio, the final gear may have a large diameter compared to the input gear. Planetary gear trends provide high power density in comparison to standard parallel axis gear trends. A planetary gear trend we can also call an epicyclic gear trend. It is made up of the three types of gears: a sun gear, plane gears, sometimes more than one, and the ring gear. Where sun gears and plane gears are external gears, and the ring gears are internal gears. The plane gear is mounted on a multiple carrier, and the plane gear orbits the sun gear and mesh the ring gears. The textbook we used is Kinematics, Dynamics, and the Design of Machining, written by Warden. It is a region 2016. One of the reference books is Kinematics and the Dynamics of Machining, written by Norton. The other is Mechanism, Theory and Application. It is written by Yan Hongsen, who is an advisor of Professor Chen. It is a good solution to use software to calculate the position, velocity, and the acceleration of mechanisms. For example, Calculator, Excel, Mathematica of MATLAB. You can also build 3D models of mechanisms using SolidWorks Pro of Autodesk Inventor, and simulate kinematics and dynamics of mechanisms using NTUST working model or algebra. I think software is frequently used in the industry, but software sometimes is difficult to reach in the university, and they are also beyond the scope of these scopes. If you have the software and want to learn it, you can contact us individually. This slide shows the grading policy. Grades will depend on a midterm exam, a final exam, and homework. Homework rules are the same as what Professor Chen said. You are encouraged to finish homework as many as possible by yourself, since it should be good preparation for exams. Indeed, all exam problems are chosen from the homework problems. Of course, they will be with trends. This slide shows the course schedule. The second part of this course starts on Wednesday, October 7. The last class is on Wednesday, November 25. The final exam is on Monday, November 13, arranged by T.A. Sebastian. The topic of static and dynamic force analysis of mechanism will take 2 weeks for teachers. You can read chapters 14 and 15 of the textbooks for details. The topic of profile can design needs 3 weeks, and the final topics of the Spur Gear and gear chains will take 2 weeks. I suggest you a useful tool for studying English. Google Dictionary is an online dictionary service of Google. It will help when you are reading articles on the web using the Google Chrome browser. You can double-click any word to view its definition in a small pop-up bubble, and click pronunciation key to pronounce this word. I give you an old Chinese proverb. When I hear, I forget. When I see, I remember. When I do, I understand. It means do the homework and exercise will help you understand this course in depth. Therefore, you are expected to do the homework by yourself. Anyway, see you next week. Bye bye.